Now, the next geometrical question, and the one which is going to concern us over most of the rest of this lecture, is a question of the discussion, the question of reflection in space. The problem is this: are the physical laws symmetrical under reflection? Put it this way. Suppose I build a piece of equipment, let's say a clock, with lots of wheels and things and hands and numbers and everything. It ticks and it works and it's got springs wound up inside. I look at the clock in the mirror. There's nothing about how it looks in the mirror. That's not. The question is this: I build another clock, which is exactly the same as that clock looks in the mirror. Every time there's a screw with a right-hand thread in here, and a screw with a left-hand thread in the corresponding place. Where the thing is marked 2 on the face, I mark 2 backwards on the face over here. Each wheel, each coiled spring of the hairspring is twisted one way, twisted in the mirror image on the other way. So when I'm all finished, I have 2 things which have both physical, which bear to each other the relation of an object and its mirror image, although they are both objects, as I wish to emphasize. Because it's a physical question, not a theoretical one. Now the physical question is, if the 2 things are started in the same condition, the springs are wound to the corresponding tightnesses and everything, whether the 2 clocks can tick and go around and look forever after as exact mirror images. I think your intuition about the laws of physics would suggest that they would. And so we would suspect that, at least in the case of these clocks, that reflection in space is one of the other symmetries of physical laws. That if I change from right to left, everything from right to left, and build otherwise the same, we cannot tell the difference. Let us then suppose for a while that this is true. If it's true, then it would be impossible to distinguish right and left by any physical phenomenon. You see, the world doesn't have to be symmetrical. For example, by geography, surely right can be defined. But for instance, I stand in New Orleans and look at Chicago, and Florida is to my right, and the air is above my head. And my feet are on the ground. So I can define right and left by geography. Of course, the actual situation in any system doesn't have to have the symmetry that we're talking about. It's a question of whether the laws are symmetrical. In other words, whether it would be impossible, it's against the physical laws to have a sphere like the Earth with dirt and a guy like me standing looking at a city like Chicago, of a place like New Orleans, but everything the other way around, so that Chicago's on the other side. It's not impossible. I mean, Florida. It's not impossible against the physical laws, or at least that's what we're discussing, to have everything change left or right. Another thing is it shouldn't depend on history. So an easy way to distinguish right from left is to go down to the shop and to pick up a screw at random. The odds are it's got a right-hand thread. Not necessarily, but it more likely has a right-hand thread. This is a question of history or convention or the way things happen to be, and is not the question of the fundamental laws different. As you well appreciate, everybody could have started out making left-hand screws. To illustrate still more clearly the whole problem, I would like you to imagine that we were talking to a Martian or someone very far away by telephone. You're not allowed to send them any samples. For instance, you say you do it by light, you can send them right circularly polarized light and say, that's right, so you watch which way it's polarized. You don't give them anything, you just give them information. You talk to them. And he is so far away or in some strange location that he can't see anything that you can see. For instance, you can't say, look at Ursa Major. Now you see how those stars are arranged? Well, what I mean by right is, and so forth. No? Well, you're only allowed to telephone him, and you want to tell him all about us. Of course, first you start defining numbers, and you say tick, tick, 2, tick, 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 3, and so gradually you can understand a couple of words and so on. And then you begin to after a while, you get very familiar with this fellow, and pretty soon he says, what do you guys look like? So you start out and say, well, we're 6 feet tall. Wait a minute, what's 6 feet? Is it possible to tell him what 6 feet is? Certainly. We say, you know how you take hydrogen atoms, and you know the diameter. 9 billion hydrogen atoms high. So you make 9 billion hydrogen atoms high, that's definite. And that's because change of scale is not something under which the physical laws are invariant, and therefore we can define absolute length. So after defining the size, and we tell him what the general shape is, it's got prongs with 5 bumps sticking out on the ends of the hands, and so on and so on. And everything's going along, and when you're all finished describing how it looks from the outside, from which you have presumably no particular difficulties, in ultimately describing. He's making a model as you go along, you see. And he says, wow, you're very handsome fellows. He said, now what's on the inside? So you start to describe the various organs on the inside. You come to the heart, say, you describe the shape of it all. Say, now put the heart on the left side. He says, the left side. Now your problem is to describe to him which side to put the heart, without him ever seeing anything that you see, or without you ever sending any sample to him of what you mean by right. No standard right-handed object. You can't figure it out. Build a frog in which every molecule is reversed. Every atom is twisted. I mean, everything is right to left of a real frog. We have a sort of a left-hand frog. And this left-hand frog would go on all right for a while, but he'd find nothing to eat because his enzymes are built, and if he swallows a fly, the fly's got the wrong kind of, unless we give him a left-hand fly. See? So as far as we know, the chemical processes and the life processes would continue in the same manner if everything were reversed. But the fact that all the proteins and all the life, from the lowest to the highest, from everything to everything else, always have the same corkscrew, is probably the most brilliant evidence to the correctness of the common evolution of all life. Because if the life is a physical phenomenon, a chemical phenomenon, then we can understand the fact that they're all from the same corkscrew, only from the idea that at the very beginning some few molecules by accident got started, a few, one, somewhere, once. But today, we really do not understand the whys and wherefores of it. Why is this the right rule? I mean, what's the fundamental reason for the whole business and so on, and how is it connected to anything else? At the moment, we've been so kind of shocked by the fact that this thing is unsymmetrical that we have not been able to recover far enough to understand what it means with regard to all the other rules. However, the subject is interesting enough, modern enough, and unsolved that I thought you'd like to hear some of the questions that are associated with it.